All right, we have spent this week talking about ratios. You have counted, we've talked about boy-girl ratios in college and how important order is in ratio. We have talked about unit rates and how you take that rate and you find the price per unit. We are headed to the grocery store to have math class there so you can practice that. But another thing I want to teach you about is a proportion. And a proportion is a set of equivalent ratios. We're going to start by just simply writing the ratio of red to green. And if I counted the red and I counted the green, then I would have a ratio of 6 to 12. Now I've divided these into 3 equal groups. And so the ratio in each group is 2 to 4. And finally, I've divided them into 6 equal groups, and I have a ratio of 1 to 2. So if you'll notice, we're looking at 3 different ratios: 6 to 12, 2 to 4, and 1 to 2. If you'll remember this multiplication chart, which was a fraction chart, which is now also an equivalent ratio chart. If we can find 6 and 12 in the same row with 2 and 4 and 1 and 2, then they are indeed equivalent ratios. And all of them, 6 to 12, 2 to 4, and 1 to 2 are in the same row. They are equivalent ratios. They can all be simplified to 1 to 2. And a proportion is a set of equivalent ratios. So your question might say, are these a proportion? Which means, are these equivalent? And I'm going to show you 2 ways to confirm yes, they are, or no, they're not. The first one is to find them on the ratio chart. 3 to 5 is in the same row as 6 to 10. So we would say yes. 1 to 3 is in the same row as 4 to 12. So we would say no. 5 to 10 is in the same row as 6 to 12. So we would say yes. So the first way to check is to use the multiplication chart. A second way to check is to see if there is a form of 1 that was used to multiply. Did I use a form of 1 here to figure out if 3/5 is equivalent to 6/10? How do I get from 3 to 6? Times 2. How do I get from 5 to 10? Times 2. Because this makes a 1, we've multiplied it by a form of 1, and the answer is yes. Here, 1 to 3, I multiplied it by 3 to get to 3, but I have to multiply it by 4 to get here. Because this is not a 1, it is not a proportion. 5 to 10 and 6 to 12. There are some times that there's not a number here to form a 1. And so we need one more way to identify if the ratios, or if the set of ratios are indeed a proportion. And you are going to do that by finding cross products. 10 times 3 is 30, and 5 times 6 is 30, and because 30 equals 30, we've said yes. All 3 ways that is a proportion. 3 and 3 is 9, 12 and 1 is 12. Because 12 does not equal 9, these are not a proportion. 10 and 6 is 60, 5 and 12 is 60, and because 60 equals 60, we do indeed have a proportion. The other thing you might be asked to do is to solve a proportion. If you'll notice, these are ratios with one of the numbers missing. And we're going to use one of those methods that we just used to decide if they were proportions to solve for them. The most common way, the way that you're probably the most familiar with, is the form of 1. Because 3 times 4 is 12, 4 times 4 is 16, and so x equals 16. 3 times 6 is 18, and 2 times 6 is 12, so y equals 12. Now this one, 6 times times something equals 10. That's not an easy one to do. That's not a basic fact, and so we might have to go to cross products. In cross products, let's do on the two that we know, and then we'll come back to this one. A cross product means that you simply multiply just like we did to see if they were proportions. So this 3 times x is 3x, and 4 times 12 is 48. And because we know we're solving a proportion, we know they have to be equal. And here you're looking at a one-step division multiplication equation. And because we have to use the inverse operation, we're going to divide both sides by 3. So this is x, and 48 divided by 3 is 16. Cross products on this one. 2 times 18 is 36. And 3 times y is 3y. And so I have to solve this equation using what we learned in our algebra unit. We're going to divide both sides by 3, choosing to divide by 3 because that's the number attached to the variable. 36 divided by 3 is 12. And so as you saw when we were using the other method, y equals 12. So now let's use cross products and solve these. All right. 6 times 30 equals 10 times f. So 180 equals 10f. So again, because it says 10 times f, I have to use the inverse operation, which means I have to divide them both by 10. 180 divided by 10 is 18, and 10 times f divided by 10 is f. That means that my missing variable in this proportion is 18. All right, we have one left to do. We can definitely do cross products. 20 times 4 is 80 and 8m, so m would equal 10. We could also look for the multiplication or division, which in this case we divided them both by 2. 8 divided by 2 is 4, and 20 divided by 2 is 10. So we would say that m equals 10. And finally, boys and girls, the ratio chart is available for use to figure out the missing variable. Find 3/4, slide your finger until you're touching 12, and this number is touching 16, and so x equals 16. Here's 2 and 3. I'm going to slide until my 3 finger is touching 18, and so y equals 12. Here is 10 and 30. And so I'm going to slide it until my top finger is touching a 6. And when it's touching a 6, my bottom finger is touching an 18. And so as you know, f was 18. And last one, we find an we find an 8 and a 20, which here is an 8 and a 20, and we slide it until we've got a 4 and a 10. All right, 6 problems to show what you know. Remember, when solving proportions, you can do cross products, you can find a form of 1, or you can use a ratio chart. All right, let's see how you did. 9/10 and 10/20. For the sake of time, I'm going to use the cross product method because that is probably the method you will eventually use the most often. 9 times 20 is 180, and 10 times 10 is 100. That tells us that this is not a proportion. This one, I'm going to use a form of 1. 17 times 2 is 34, and 15 times 2 is 30. So this is, yes, a proportion. And if you wanted to use the cross product method, you would do 17 times 30 is 510, and 15 times 34, anybody guess? It's 510. So because both of these are 510. The answer is yes, they're a proportion. 5 to 6 and 12 to 10. Remember that if I were going to use a form of 1, they would have to go straight across the top and straight across the bottom. If I use the cross product, 6 and 12 is 72, and 5 and 10 is 50. And because 50 does not equal 72, we are going to say they are not a proportion. And now down here, you had to solve the proportion. And so we're going to turn these into equations using cross products. 6 times n is 6n, which equals 5 times 12, which is 60. And when I solve 6n equals 60, I divide both sides by 6, so n equals 10. 6 times 2 is 12, 5 times 2 is 10. A form of 1 could have helped you on that one as well. Let's look at 10 times 4, which is 40, and m times 8 is 8m. Because this says multiply by 8, I'm going to divide by 8. 40 divided by 8, m equals 5. Last one, 2 times 9 is 18. 6 times f is 6f. 18 equals 6f. Divide both of these by 6, and you get f equals 3.